Hi, my name is Vikram Trivedi and I am here to present my project video for my project in AI and machine learning. And in this project we are building a machine learning model to predict the energy output of combined cycle power plant. And for this machine learning project we have been provided with a set of 9570 input data points shown over here in this Excel file. These are the four input uh, variables, features, independent variables depicted by x1, x2, x3 and x4, and this is the energy output or power energy output depicted by y. Since we have more than one independent variables to predict the output variable or target variable y, our modeling approach for building a machine learning model for this project would be to build an output machine learning model with regression, multiple regression analysis. And for this we have designed two algorithms for two different models with two different sets of input features or independent variables. In one algorithm we have selected x1, x2 and x3, these three independent input variables, to predict our output variable, that is energy output denoted by y. And in the second algorithm, that is model number 2, we have selected x2, x3 and x4 as three independent input variables to predict our target variable y or energy output, right? So, and how we are going to do that? So we have total input data points of 9570, right? And out of that we have selected a sample size of 390 data points to train, validate, cross validate and test our machine learning model. How we are doing that? For validation, for training the data, we are using 233 data points. For cross validation set with two folds, we are using 79 data points, and for test set we are using 78 data points. We have shown it over here, right? This the ML model, the machine learning model, uh, uh, depicted over here with these two algorithms, one with higher R square value and lower standard error, will be selected for final deployment after we have tested it through the test set. The reason for doing that is the model with higher R square value depicts higher strength of relationship between our independent variables, right, x1, x2, x3, x4, in predicting our target variable, that is the energy output depicted by y. and and the equation or the regression equation giving lower standard error makes it a good fit for the training data as well as the new data. So let's look at both the models and how they have performed. So this is the working for model number 1, algorithm 1, for training data set. It gave us an R square value of 0.91 and a standard error of 4.7 for training set. For validation set with k-fold 1, same, more or less the same. Similarly for cross validation set 2, k2, more or less the same. Standard error has in fact gone down to 4.5. And in the test set, in the evaluation set, when we test the set when we test the algorithm, we got an R square value of 0.92 and standard error of 4.5. Whereas in case of model 2, algorithm 2, we are having a lower R square value of 0.78, 0.78, 0.8 and a higher standard error of 7.2, both in case of the training set, cross validation set as well as in the test set. So the final inference for us in this case is we are going to select the algorithm 1 with input variables of x1, x2, x3 for deployment in case of our machine learning project to predict the energy output of CCPP. Because it is having a higher R square value of 0.92 and lower standard error of 4.5 as compared to the algorithm number 2. Thank you.